Hello everyone. So this week we have started with our new lesson, which is counting. Um, First of all, I'm going to revise the important things that we have learned. What's the meaning of the word factorial? Factorial, for example, if we have 2 factorial, means 2 times 1. 3 factorial is 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. So the word factorial or this symbol means that you have to go backward until you reach the number 1 and then you multiply them. So the general rule of n factorial, it's n times n minus 1 times n minus 2 until you reach the number 1. Okay, as you can see here, n plus 1 factorial is n plus 1 times n factorial. Of course, you can switch it as much as you want. Like, for example, if you have 3 factorial, it's 3 times 2 factorial. 5 factorial, it's 5 times 4 factorial. Uh, I will summarize the whole lesson in one map. Okay, I'm going to put it aside. And then I'm going to solve some exercises, okay, that we have solved in class. So we are in the lesson counting, okay? Sorry. Counting. In counting, we have learned that we have, okay, what's this? Just a second. In counting, we have learned that we have, okay, some cases. Okay, here's one. We have with repetition, okay, and we have without repetition, without repetition. Okay. If we have with repetition, then we have only one rule, which is n to the power p. N, it's the total number of cases. P, it's what I'm trying to choose. If we have without repetition, in this case, we have 2 cases, okay? Let me just write them quickly. Okay, both of them are without repetition. If P is less than or equal to N, then we use APN. If we have P exactly equals to N, then this is permutation, then we use N factorial, okay? That's our whole lesson. So whenever you read the question, you ask yourself, do we have repetition or we don't have repetition? If we have repetition, then directly it's n to the power p. If we don't have repetition, then I ask myself if I'm getting values less than the total or equals to the total. Okay, if it's less than the total, I use APN. If it's equal to the total, I use n factorial. Let me start with some of the examples. I'm going to go directly. So this map summarizes all these cases that you are going to see here. I will start uh, in question number 8, okay? In question number, how many permutation? Whenever you see the word permutation means they are using 3 out of 3 without repetition. So how many permutation are there among the elements of set 1 to 3? So it's 3 to the power, okay, 3. Sorry. It's 3 factorial, which means 6 cases. Let us do them using a tree. Okay, the tree diagram that I taught you in class. So we start with 1 or 2 or 3, and we start listing the cases. So 1, 1, you cannot put 1, 1 because no repetition. So 1, 2, 3, or 1, 3, 2. Do you have any other cases? No. 2, 1, 3, or 2, 3, 1. 3, 1, 2, or 3, 2, 1. So how many cases did we get? 6 cases, and 3 permutation is 6. Okay? Let us do another exercise. So I'm going to go, for example, for question number 9. In number 9, okay, we have in how many different ways 5 persons can stand in a line. So I have a line, okay, where 5 persons need to stand. So of the 5 persons, they are going to sit out of 5 in the line. And of course, a person cannot stand in 2 different places at the same time. So we are in without repetition, where P equals N, so this is factorial. So the answer is 5 factorial. Okay, but if you look at number 10, I have 20 students and I'm looking for the first 5. So the first 5 out of 20, of course, the first 5, they cannot be with repetition because the first cannot be second at the same time. So I'm without repetition where the P is less than N. So I use A, 5 out of 20. Okay? In number 11, we have a question that summarizes everything if you want. So we have the word maison, and I need to do 3-letter words of this word, original one. But they didn't mention if they wanted distinct or not. So repetition is allowed. So repetition is allowed, and I'm using 3 out of 6. Here we have 6 letters. So it's with repetition and power P. So it's 6, the total power my choices, it's 6 power C. And number 2, the same thing, but they mentioned the word distinct. When they mention the word distinct means without repetition, where I'm using only 3 out of 6, so it's A, 3, 6. Now 4 distinct letters, so also it's for A, 4 the 6 now. Now 6 distinct letters, so without repetition, and I'm using 6 out of 6, this is 6 factorial. Okay, so this question actually summarizes everything that we have learned. Let me solve some other important questions. Okay, great. I'm keeping the map, okay? In question 12, a board of 4 members is going to be formed from the 30 students in a class, a president, a vice, a secretary, and a treasurer. They didn't mention if we have repetition or not, so they are choosing 4 students out of 30 without mentioning if it's repetition or not. But you have to know, can a president be a vice president at the same time? Of course not. So I'm without repetition, where P is less than N, so this is A, 4 out of 30. Okay? There's an important question that I need to solve. It's, I think, number it's number 25. We have 4 books of mathematics, so 4 books of mathematics. We have also 6 books of physics and 2 books of chemistry. They need to put on a shelf. So I want to put them on a shelf in a way that the same subject, they have to be beside each other. So here you have to pay attention that I have 2 counting. The first one, it's about the subjects, and the second one is about the same book of the same subjects. What I'm trying to say is I can put on the shelf the math books first, or then the physics, then the chemistry, or the physics first, then the chemistry. So if I want to talk about subjects, how can I place them in on a shelf? Okay, regarding the subject, it's 3 out of 3, so, and of course without repetition, so it's 3 factorial. So this is the first accounting I have to solve. Later on, suppose I put them in this order: math, physics, chemistry. We have 4 books of mathematics, they need to be beside each other, okay? These books also, they can be switched as long as they are beside each other. So the math book alone, they are 4 factorial. The physics, they are 6 factorial. And the chemistry are 2 factorial. Okay, but all of them, they are multiplied by 3 factorial regarding their subject. So this is an important question because you have 2 factorials or 2 counting inside one question. So you have to pay attention to this very well. The order is important because if I put math, chemistry, physics, or math, physics, chemistry, and also the order of the books themselves regarding their subject is very important to put them beside each other. Okay, I think I have another exercise. Let me check. Just a second. Let me erase this, which is similar to this one. Okay. Sorry. I think it's question. No, it's before 25, I think. Yes, it's exercise 20. I have 3 boys and 2 girls. They need to sit on a bench. Okay, they need to sit on a bench. And they need to sit beside each other. So the boys, then the girls, or girls, then boys. So here I have only regarding their sex, if they are boys or girls, we have only 2 factorial. And then how many boys do we have? 3 factorial. How many girls do we have? 2 factorial. So it's the same question, but with different values, okay? So that's our lesson. Of course, we have a lot of exercises that you can practice alone. As long as you ask yourself if you have a repetition or without repetition, and if you have the same number of elements or less, you can use one of these rules.